Okay, let's go over your homework questions. So question number 1 from the Electrostatics review says, two charges Q1 and Q2 are separated by a distance r and exert a force F on each other. What new force will exist if, for A, Q1 is doubled? So it's saying you have all these things, you could fill the numbers in, get some value. Now we're going to double Q1 without changing anything else. If we double Q1, what happens to the force? Well, it should double, right? If you double one number and leave everything else the same, F should double. B says, what if both Q1 and Q2 were cut in half? So if we cut Q1 in half, F should be half. If we cut the other Q in half, F should be half. So if we cut both of them half at the same time, then the force should be 1/4 of what it was. C says, what if you triple R? So if you make R bigger, F should get smaller. But if you triple it, that's going to get squared. So F should get smaller by a factor of 9, or it should be 1/9 as great. D says, what if R is cut in half? So if R is smaller, F should get bigger. If R is smaller by a factor of 2, then F should get bigger by a factor of 4. And then the last one, what if you tripled Q and doubled R? So if we triple Q, F should get bigger by a factor of 3. If we double R, F should get smaller by a factor of 4. So in the end, F should be 3/4 as big. Hopefully that makes sense. All right, number 2, we have 2 electrons in an atom separated by a distance of 1.5 times 10 to the negative 10 meters. What is the force between them? So this is just math. 9 times 10 to the 9th Newton meters squared per coulomb squared times 1.602 times 10 to the negative 19 coulombs. That's the charge on an electron. And there's 2 of them, so you could either rewrite it out again the second time, or you could have just squared that charge. And then on the bottom, 1.5 times 10 to the negative 10 meters. And then you're going to punch all this in your calculator. So 9 to the 9th times 1.602 to the negative 19 squared divided by 1.5 to the negative 10 squared. And you should get 1.02656 times 10 to the negative 8 newtons. Now, depending on your calculator, when it comes up, you might just see point and a whole bunch of zeros and a 1. You need to put it in scientific notation to get the rest of the decimals, okay? Number 3 says object A has a charge of 1.8 microcoulombs, and micro is times 10 to the negative 6, if you remember from grade 11 when we did the metric unit. So again, they're giving you 2 charges and they're asking you to find the force. So it's going to be 9 times 10 to the 9th Newton meter squared per coulomb squared, and then 1.8 times 10 to the negative 6 coulombs times, I forgot, up here you could put the negatives on both of your electrons if you want, but they're just going to cancel out anyway because a negative times a negative. Down here, one of them has a negative and the other doesn't, so make sure you don't forget it like I almost did. So 1.8 times 10 to the negative 6 and negative 1 times 10 to the negative 6. And it says that the distance they are apart is 14 millimeters, or 0.014 meters, and you're going to square that. So then you type it in, 9 to the 9th times 1.8. I'm going to multiply the 1.8 and the negative 1 together at the same time, exp, and that'll give me negative 12, and then divide it by 0.014 squared. And I get negative 8.2653 times 10 to the 1. Whoops, I had my calculator in scientific notation. So 82.653 newtons. The negative means, remember what a negative force means? It means it's an attractive force. All right, number 4, two negatively charged objects with charges of -5 times 10 to the 5th are 0.2 meters from each other. What is the force acting between them? So again, it's Fq equals KQQ over r squared. So 9 times 10 to the 9th Newton meter squared per coulomb squared. Both charges are -5 times 10 to the -5 coulombs, and there's 2 of them, so this time I'm going to save time and just put a squared there. And they're a distance of 0.2 meters apart, which of course has to get squared. So 9 to the 9th times 25 to the -10, sorry, trying to save time here, and then divide by 0.2, whoops, I was thinking about doing that in my head. 0.2 squared. And you get this at a scientific notation, I think, assuming I typed it in correctly, 562.5 newtons. Okay, number 5 says two charged objects exert a force of repulsion of 2 newtons on each other. If each charge is -3 microcoulombs, how far apart are they? Okay, and so we have Fq is equal to KQQ over r squared. This time we are solving for r squared. So KQQ over F. So 9 times 10 to the 9th Newton meter squared per coulomb squared. It said that each charge was -3 microcoulombs. So again, times 10 to the -6. And that gets squared. And it says the force is 2 newtons. So 3 squared is 9. 9 times 9 is 81 divided by 2. Sorry, I should probably pay attention to what I'm doing. Divided by 2 is 40.5 maybe. And then the decimal. So I think, assuming I typed it in correctly while I was talking, I think it's 0.0405, but that's r squared. So then you have to take the square root. And you should get an r of 0.20125 meters. Number 6 says, an object with a charge of etc., second charge, attractive force, how far apart are they? So exactly the same idea this time. Looking for r again, there's just one difference. It says attractive force. And that means you're going to need to put your force in as a negative, because remember, an attractive force is a negative thing. So we have 9 times 10 to the 9th. We have 1.92 times 10 to the -6 coulombs times -2.56 to the -6 coulombs. And then it says the attractive force is 4 newtons. So it has to go in as a -4, because otherwise you're going to be taking a square root of a negative number. Now, most of you probably just dropped the negative and took the square root. But that's not really quite legit math. Legit math would be, I think that was supposed to be a 6. Legit math would actually be looking after the negative. Okay, so times 2.56 to the -6, and then you're going to divide it by the -4. I just didn't put the negatives in. And then you're going to take the square root. And again, assuming that I typed it incorrectly, I think you get 10516 meters. Number 7. How far apart are 2 electrons if they exert a force of repulsion of 8 newtons on each other? Again, exactly the same thing, looking for r squared. And this is me checking to see if you know the charge on the electrons. So it's giving you a chance to use it. So 9 times 10 to the 9th Newton meter squared per coulomb squared, charge an electron 1.602 to the -19 coulombs. Yes, it's negative. Does it matter? Nope.